Hey class, welcome back to day two of group battles. The question that we're going to consider now is as follows. Simplify and express your answer using positive exponents. So t to the negative 4 times t to the negative third divided by t to the negative 4. You guys are going to have a full minute to talk about it and put something on the whiteboards. All right, welcome back. All right, so class, the final answer, if we look at it, should be 1 over t to the third power. Now, in order to get there, what we needed to do is we needed to understand that that number, that exponent on the denominator, we're going to flip it over 1 and take the exponent and switch the sign. So we've gone from -4 to -4 to +4. So now I'm just adding my exponents like I normally do. All right. I got a -4, I got a +4. That simplifies, goes away, just leaves me with a -3. T to the -3. Anytime I see a negative, flip it over 1 and switch the signs. All right. Let's consider our next question. All right. And our next question, I'm asking you, simplify the expression using positive exponents. All right, you get a full minute, pause the video, and tell me when you come back with. All right, class, welcome back. So hopefully you had information from my last question to use here. So we just start adding our exponents. We bring down our 7, we bring down our -3, we bring down our -9. So we'll have 7 minus 12. That difference is -5. All right, when we see a negative, flip it over 1 and then switch the sign. It's now going to be 1 over w to the 5th power. All right, class, welcome back to Group Battles Day 2. Let's consider the next question. It says simplify and express your answer using a single exponent. All right. All right. We're going to give you a full minute for you to think about it, talk about it, and put something on that whiteboard. Pause the video. All right, class, welcome back. How we doing? All right, so let's deconstruct this. So our final answer is 64, a to the 10th power. Now to go from here, to get to here, we have to know that it says we can only have a single exponent in our answer. So our information here in blue is technically correct, but this whole thing about the single exponent creates the additional step. So as you can see, we take there's an invisible 1 over the 8. So I take that invisible 1, multiply it by 2, I get 2. I take the 5 over the a, multiply that by 2, and I get 10. That's sort of straightforward. We just need to take that 8 and multiply it by itself to get our 64. Okay? Not a tough problem, but it is something that if you have not seen before, it could get you banged up. Let's consider the next problem here. Here we're dealing with 12g raised to the 6th power raised to the 2nd power. You have another full minute. Think about it, talk about it, and your group put something on that whiteboard. Pause the video. All right, class, welcome back. Let's take a look. So on our final answer, we get 144g to the 12th power. Now, how do we get there? Well, we start with the idea that if I take the one, the little one that we don't see, the invisible one, and multiply that by 2. That gets me back to 12 to the second power. And if we square 12, we get 144. And the G is pretty straightforward. 6 times 2 is 12. So we have G to the 12th power. Okay, we're going to try another question. Pause the video when you're ready to load that. All right, welcome back to Group Battles Day 2. We are now on our 0 power rules. So, team, you talk about this. You don't need a full 30 seconds on this. I want to say maybe 15 seconds at the most. Consider what the value of parenthesis 5x to the third, y to the 4, parentheses 0. And then come on back. Make sure you have an explanation. All right, class, welcome back. So this shouldn't have been difficult, but I want to make sure not only do we know it's 1, but we know why it's 1. So let's start at the very beginning. Anytime I have anything raised to the 0 power, what I'm essentially doing is I'm saying that I'm taking whatever that number is and I'm dividing it by itself. So I'm literally putting this number in my numerator and putting that number in my denominator, and I say, well, what do I have left? Well, I have 1 whole. So that means that when we have this 0 power rule, no matter how, crazy the number or the question might look like, anything raised to the 0 power will be 1. So 2 raised to the 0 power, 1. 1.234 raised to the 0 power, 1. All of this stuff here raised to the 0 power, yeah, you got it. It's going to be 1. Okay? So, literally, these problems, aren't as ugly once we know what they really mean. Okay? So let's brings us to the question that we're going to work on right now. You're going to get with your talk this out with your groups, and we're going to consider the problem here, where I have negative 3x over negative 4 times y in closed parentheses raised to the negative 4 power, and that's all over, you guessed it, 1. All right, freeze the video, come back in 30 seconds. All right, class, welcome back. All right, so I kind of gave you a huge head start right at the very beginning by letting you know that all of this stuff in the bottom is irrelevant. It's going to be 1 because there's a lot to deal with here. So let's just start at the end and work backwards. To be clear, my final answer should have been x raised to the 16th power over negative 3 raised to the 4th power times y raised to the 4th power. Now, how did I get there? So I start with my initial statement. All of this stuff in the parentheses is being raised to the negative 4 power. And I just very methodically distribute the negative 4 by each item. So negative 4 is going to be distributed by 1. So we got negative 4 here. Now negative 4 is going to be distributed by the, we multiply by the negative 4 here. We have negative 4 and negative 4. And then negative 4 is going to be multiplied by that 1, and that's negative 4. So then we just simply do what we do. That comes down. Negative times a negative gives me a positive. That comes down. Now, the only thing here that is a positive exponent is the 16. Have a negative exponent here and a negative exponent here. Our rule is we flip it over 1 and we change the sign. So negative 4 becomes positive 4. Negative 4 becomes positive 4, switched over 1, so that's our final answer. Okay, class, so that is group battle, day 2. We're going to leave you with 2 challenge questions. All right, and here's the challenge question. Okay, which of these are equivalent? It reads, a computer application generates a sequence of musical notes using this function. where n is the number of notes in the sequence and the note frequency in hertz. Which function will generate the same note sequence? Choice 1, choice 2, choice 3, and choice 4 are as follows. Um, which is going to be an equivalent frequency? All right, pause the video. You guys are going to have a full 2 minutes to think about this.